Alright, chat. Sorry about that. We had some technical difficulties there. I don't know what happened to the scene I had set up. I guess since there was an update to Streamlabs, we had a little bit of a hiccup there. But anyways, it's Monday. And it's time for some math. So, we will be doing right triangle trig today. I need to check on one other thing real quick, and then we should be good to go. Alright, yeah. Right triangle trig time. So, today we're going to be doing right triangle trig. That means we're going to be talking about SOHCAHTOA. If you don't know what SOHCAHTOA is, I'll be introducing that here in just a moment. But I hope everybody is having a good day, and I hope it was a good Columbus Day. So let's get right into it. Let's talk SOHCAHTOA. And with SOHCAHTOA, we were talking specifically about right triangles. So when we talk about SOHCAHTOA, let's go this way. Krakatoa. We were talking about right triangles. If you don't know what a right triangle is, it looks like this. If you know how to draw lines correctly, it has a little square here that means 90 degrees. And then you pick either this angle or this angle to be your theta. Theta allows you to have a basis of what side you want to look at. So in this case, theta, we're looking towards this side. That would be our opposite side. This side would be our adjacent side. And this side would be your hypotenuse or the diagonal. This is important because for each of these, we are going to go through and talk about the trig functions that they identify with, which is sine, cosine, tangent, and then over here, the reciprocal identities, which would be cosecant, secant, and cotangent. I always write them out this way. That way they're in the same order and directly across as their reciprocal. Because when you first go through and learn about trig, there's a lot of people that will go and get confused and they'll think the two S's go together and these two C's go together, which isn't the case. So you always want to take your time and pay attention to which thing you're looking at. So when we talk about sine, you have to go and look at opposite over hypotenuse. So that's your so for SOHCAHTOA. So you go opposite over hypotenuse. Later on, this is actually referenced a little bit differently, and I'll write it out over to the side in a different color. For cosine, you have adjacent over hypotenuse, so adjacent. For tangent, you have opposite over adjacent. And if you know those three, then you know the other three, because the other three are the exact same. You just flip them over. So cosecant is hypotenuse over opposite. Here you have hypotenuse over adjacent. And here you have adjacent over opposite. So if you know the first three, as long as you line up the other three correctly, you automatically know their reciprocals. And I won't identify this for cosecant, secant, and cotangent because, again, they're reciprocal, so you don't have to worry about it too much. But we'll talk about for sine. Later on, you'll talk about unit circle, and that's important because sine always goes with y, and then hypotenuse in that case is known as r. That is really hard to see, so un momento. Green marker is a no-go. Lessons learned. All right. Y over r, where y is the y coordinate because it's vertical, and then r is your diagonal because that when you talk about unit circle, you're talking about the radius. For cosine, you're talking about x over r, and then for tangent, you're talking about y over x. And then again, cosecant, secant, and cotangent would just be the reciprocal functions. All right, so that's the general setup, and really the only other thing you need to know is good old Pythagorean's theorem. Pythagorean's theorem, if you don't know it, you should. So, Pythagorean's theorem is an important part of right triangle trig because it lets you find the side that you're missing. It is a squared plus b squared is equal to c squared, where c is your hypotenuse, and A and B are whatever leg you feel like designating them to on the triangle. So in this case, like, you could call your adjacent the A side, opposite the B side, and the hypotenuse is always the C. All right, so that gives you the general consensus of what we're going to be dealing with. And it's not overly complicated. I'm not going to get into special triangles tonight. I will talk about a couple things that's interesting about right triangles. So our first example is one of those things. And it has to deal with the fact of, if you have a right triangle that says, so we have a right triangle, and you know this side's 3 and this side's 4. Okay, and we're going to be over here and say, find all 6 trig functions. To find that other side, you're going to go over here and say, okay, well, Pythagorean's theorem says 3 squared plus 4 squared that is a C because I'm thinking ahead. 4 squared is equal to C squared. All right, and if we're looking for C specifically, that means we have to do the square root. 3 squared is 9 plus 16. So the square root of 25 is equal to C. So this hypotenuse is equal to 5. It just so happens it's a 3, 4, 5. There's a couple other triangles that actually work that way, but I'm not going to get into too much of that. Most of the time, just use Pythagorean theorem to find the missing side, and you're all set, rather than trying to remember special triangles that happen. So once you have that information, it's as simple as just making sure you write out all 6 trig functions correctly. So you have sine, cosine, tangent, and then after, for your reciprocal to sine is cosecant, secant, and cotangent. And then you just have to remember SOHCAHTOA. That's all you have to do. So remember your and I didn't put my theta on here, so we could really mess this up. Theta makes it where it's perspective based, so we'll look at this 2 different ways. We'll look at it this way, and I'll talk about the other way to look at it. So if this is where your theta is, because I didn't place it just a second ago, that is going to be opposite over hypotenuse for your SO. Ca is opposite or adjacent over hypotenuse. And then TOA, so O opposite over adjacent. And again, once you know those 3, then you just flip it and you know the other 3. So 5 over 4, 5 over 3, 4 over 3. Bamboozle, you're done. Now, what could happen is if you look at the other theta that exists, if you pick one theta, so for instance, if this is our new theta, we get different answers. Because now you're having to look at this being the opposite, because it's where you're looking towards. So then this answer becomes 3 over 5. This becomes 4 over 5. And this becomes 3 over 4. And then you have to flip all these. So it's important to know that what you have going on here is whenever you change theta, you have to look at the perspective it's looking at. So opposite is always the angle, or you're looking towards the other side. So this becomes opposite, this becomes adjacent, this becomes hypotenuse. Uh-oh, did I mess up, Ross? Opposite over hypotenuse, adjacent over hypotenuse. I didn't mess up, man. Opposite over adjacent. Over here making me think I messed up. I did mess up. Oof. That's tough. Okay, I did mess up. I admit defeat. I messed up. Big oofs. No, I did it again. Okay, so there you go. All right, it's not overly complicated. We'll do another one. But overall, you're going to get two sides. Use Pythagorean theorem to find the other one. And then go through and just use SOHCAHTOA. All right, so if we do the same thing again. This time we'll label a theta. We'll just pick random things. I don't know. 7. Do I care about it being even? Not really. 3. And then something that we don't know. All right. This time, we're still going to find all 6 trig functions. So find all 6 trig functions. The only difference is now we know C and whatever side you want to label as being 3. So we'll call that A. We'll stay consistent with what we wrote out earlier. So you're going to have 3 squared plus B squared equals 7 squared. And really what happens is now you have 9 plus B squared equals 49. And you have to think about moving this 9 to the other side. So we end up with B squared equals 49 minus 9. Or B equals the square root of 40. We could rewrite that a different way when we do square root of 40. And we could simplify a little bit. Which means we can come over here and say, okay, well, square root of 40 actually simplifies down into 4 times 10 under the square root. And we know the square root of 4 is 2. So we get 2 square root of 10. That's not horribly important, but it does allow us some reducing later on, so we'll go ahead and get that. Now when we go through, we're still doing those same 6 trig functions, so we're still going to go and look at the same order. If you stay consistent, it makes it really hard to mess up. So sine, unless you're me like earlier, cosine, tangent, and I'm going to wait. I might end up writing the other ones down here. So cosecant, secant, and cotangent. And there's a reason I'm going to do this because I'm probably going to need some room to work things out and explain something. So for sine, we know we have opposite up here. We have opposite, so we have 2 square root of 10 over 7. Which means then we come over here and we're like, okay, well cosine is adjacent over hypotenuse, so we have 3 over 7. And then we have 2 square root of 10 over 3. All right, that was all great. The problem is when we get to cosecant, secant, and cotangent, let me look at cosecant specifically first. So with cosecant, we have to do what's called rationalizing the denominator. So with cosecant theta, you end up with 7 over 2 square root of 10. All right, you can't have a square root in the denominator. So what needs to happen here is you have to multiply the numerator and the denominator by square root of 10. Which means you end up with 7 square root of 10 over, well, square root of 10 times square root of 10 is 10. 2 times 10 is hopefully 20. So now you have 7 square root of 10 over 20. And if you come over here and you do secant theta equals, again, well, this time it's nice because you're going to just get 7 over 3. Done. And then you come back and you say, okay, well, now I need to find cotangent theta. And when that happens, I get 3 over 2 square root of 10. And I still have to follow that same principle of multiplying by square root of 10 over square root of 10. Which means when I get down here, I'm back to having 3 square root of 10 over 2 times 10 is going to be 20. I want to keep consistent with colors. Sorry about that. 3 square root of 10 over 20. All right. That's pretty much it. There's nothing that makes this super crazy. It's very straightforward. And it's really the basis that you start off with when you kind of learn about trig, is you talk about right triangles, and then you get to go into the other fun stuff like trig identities, improving identities, trig graphing trig functions, using the unit circle, and all that fun stuff. But I wanted to do something that's a little bit, not necessarily it's on the easier side, but something that a lot of people tend to struggle with, and just have a little bit of issues starting off with, and that's right triangle trig. I hope everybody enjoyed tonight. Sorry for the one mistake I made on the previous problem. But again, I've been using deco boards. If you're interested in those at all, let me know. I can get you some contact information for that. Everything that I've had from them has been fantastic so far. I'll be working on getting a bigger board soon to hopefully have like full screen of the board and being able to write across it. I think that'll look a lot better than what we're doing now. But that's coming over time. Really appreciate y'all coming out. If you enjoyed the content, always feel free to hit the follow button. If you're watching on YouTube, feel free to subscribe. This video should be updated tonight. If not, it'll be updated tomorrow or uploaded tomorrow onto YouTube. But I appreciate y'all coming out, and some games will be coming up here in just a minute with our new overlay and spooky alerts. See y'all in just a minute.